The dangers revealed so far, ghost particles, supernova, and rogue black holes, were only the beginning. Now, the threats grow larger, darker, and more mysterious. In Part 3 of Quantum AI discovers hidden dangers in the universe, we confront the hidden currents of dark matter, the breathtaking violence of colliding galaxies, and the ultimate question of how the universe itself might end. This is not just the science of space. This is the science of our future. Dark matter currents. We live inside a mystery. Every galaxy, every cluster of stars, every motion of the cosmos is governed not just by the matter we can see, but by something invisible. Dark matter. It outweighs normal matter by more than 5 to 1. Without it, galaxies would fly apart. Without it, stars would not orbit as they do. And yet, no one has ever seen a single particle of dark matter. Quantum AI, fed with decades of rotation curves, gravitational lens maps, and cosmic background data, was asked a simple question: how exactly is dark matter arranged? The answer shocked scientists. Dark matter, the AI suggested, does not sit like a quiet halo around galaxies. It flows. It forms rivers, streams, and currents of invisible mass winding through space. These hidden highways may be guiding stars, planets, and even galaxies themselves. Unseen, but undeniable. For Earth, this realization carries unsettling consequences. If our solar system is drifting through a dark matter stream, it could subtly alter planetary orbits over millions of years. If denser clumps exist, they might disturb Earth's climate, influence volcanic activity, or even spark extinctions. Some physicists whispered a darker thought. What if these currents interact not just with planets, but with stars themselves? A dense surge of dark matter passing through the Sun could ignite unusual reactions in its core, destabilizing its delicate fusion balance. A surge through Earth could unleash chain reactions deep below our feet. We once thought of dark matter as distant and irrelevant. The AI reminds us, it may be flowing through us right now. Galaxy collisions are future written in the stars. Galaxies are not still islands in a calm sea. They move, they collide, they merge in cosmic dances that last billions of years. And our home, the Milky Way, is not exempt. Astronomers have long known, in about 4.5 billion years, our galaxy will collide with its massive neighbor, Andromeda. The event will be spectacular. Two spirals of hundreds of billions of stars smashing together in slow motion. Quantum AI resimulated this future with unprecedented precision, and the results were breathtaking. In about 2 billion years, Andromeda will grow larger in the night sky, outshining every constellation. By 3.8 billion years, the galaxies will make their first close pass, their arms stretching, twisting, and flinging stars like sparks from a fire. Over the next billion years, wave after wave of gravitational chaos will fling solar systems into new orbits, some into intergalactic exile. Finally, the cores of the Milky Way and Andromeda will merge, their supermassive black holes spiraling into each other, colliding in a burst of gravitational waves powerful enough to shake spacetime itself. For Earth, the timing is cruel. By then, our sun will be swelling into a red giant, preparing to engulf Mercury, Venus, and perhaps even Earth itself. Whether humanity endures or not, our sky will be rewritten forever. The AI simulations showed us the truth. Even galaxies are mortal. The familiar constellations that guided human history will be erased. The Milky Way itself will vanish into a new elliptical galaxy, sometimes called Andromeda. The universe does not promise permanence. Not for planets, not for stars, not even for galaxies. Doomsday theories: how the universe could end. The universe has a beginning, the Big Bang, a moment of fire and light, when space itself expanded from nothing into everything. But if there was a beginning, there must also be an end. For centuries, philosophers asked, how does it all finish? Today, quantum AI analyzes cosmological data and reveals 3 terrifying possibilities. Heat death, the eternal silence. The AI's first scenario is the bleakest. Heat death. In this vision, the universe expands forever. Galaxies drift apart until even their light can no longer reach one another. Stars burn out, leaving only dead embers. Black holes evaporate over unimaginable timescales. Eventually, all matter decays into a thin mist of particles, spread so far apart they may never collide again. There is no explosion, no collapse, only silence, a cold, eternal night where nothing happens, because nothing can. The AI's probability models suggest this is the most likely fate. And though it lies trillions of years ahead, the thought is unsettling. A cosmos where even memory vanishes. The Big Rip, when space itself breaks. Another model is far more violent, the Big Rip. Here, dark energy, the mysterious force accelerating the expansion of the universe, does not remain constant. Instead, it grows stronger with time. First, galaxies separate. Then stars are torn from galaxies. Then planets are ripped from stars. Finally, in the last catastrophic moments, even atoms are shredded as spacetime itself stretches beyond endurance. The AI calculated that if dark energy evolves just slightly differently than we expect, the Big Rip could arrive not in trillions of years, but in only tens of billions. A universe devoured by its own expansion, leaving nothing behind. Vacuum decay, the sudden end. Perhaps the most horrifying fate is vacuum decay. Our universe may not be in its true lowest energy state. Instead, we may live in a false vacuum, a delicate bubble of stability. If that bubble ever collapses, a new region of lower energy vacuum would appear, expanding at the speed of light. Everything inside it would be annihilated. Physics itself would be rewritten. Atoms, stars, galaxies gone, placed by laws we cannot even imagine. No warning, no survival, just instant erasure. Quantum AI detected subtle hints in particle physics data that make this more than speculation. It is a small probability, but not zero, and that is enough to make the thought terrifying. Dark matter currents, galaxy collisions, and doomsday theories. Part 3 showed us the edge of the abyss, but the universe still hides even deeper secrets. Don't miss what comes next. Subscribe and stay with us on this journey.